Hello viewers, so we have this question under chemical kinetics. It says if 75% of a first order reaction was completed in 60 minutes, 50% of the same reaction under the same conditions would completed in. Now we are looking for the time it will take 50% of the same reaction under the same conditions to complete. Now the formula you need to solve this question is the rate constant K is equal to 2.303 divided by T, that is multiplying by log of the initial amount on top there in form of concentration or mass or anything that you are using, but we're talking about the initial amount over the final amount. So on this part here, we are saying on top there you have the initial amount. In this case, we are using concentration, but it can be initial mass, it can be initial amount of substance, anything over the final amount. So this is the formula you need. You can also use another formula that uses natural logarithm. This one is using standard logarithm, but we have the one that uses natural logarithm. That one will be K is equal to 1 over T, that is multiplying by natural log of, still we have the initial concentration or initial amount on top there divided by the final amount down here. So these two will still give you the same answers you are looking for. You can use either this one or use the one that uses natural logarithm. You still get the same answers. In this video, we are going to use the one that uses standard log. So let's get rid of this part here. Now we're given two conditions here. We have the first one that is talking about 75% being used, and that is used in 60 minutes. And then we have another that is talking about 50%, and we are looking for the time it will take for that to be used or completed. So let's start with the 75% one. So the initial amount is always 100%. We consider to say we have 100% of the initial amount in percentage form, which is basically 1 in standard form. And then we are told here to say we have used 75%. So it implies to say out of the 100%, 75 will be used. So we need to look for the amount that will remain after 75% has been used. So we'll say the initial amount, which is 100% minus 75%, which is used. And when you do that, what we are getting is a 25%. All right. So that 25%, we said 100% is 1 in standard form. The 25% in standard form, you divide by 100%, and what you get here is 0.25. So it implies to say the amount that will remain after 75% has been used is 25%, and that 25% is what we are representing as 0.25, and the 100% is what we're representing as 1. So yeah, after doing that, you come back to your formula and replace. We'll say our K is equal to 2.303, like that, divided by T. Now the T for this one is given to be 60 minutes. So we'll replace 60 there, and this will be given to log of the initial amount there is 100% is 1. Then this is divided by what will remain is 0.25. So this is what we have there. This will be equal to our K is equal to 2.303, like that. Then this is divided by 6, which is going to be multiplied by log of. Now 1 divided by 0.25, this is giving us a 4. So it will be log 4 on the other side. Now we can proceed here to find what 2.303 divided by 60 will give us, but in this case, I'm not doing that. We'll see the reason why I'm not doing that, but you can do that still. Let's proceed. So this is the part of the 75% and the 60. Let's look at the 50%. So we get rid of that part. Again, we need to determine the initial amount and the amount that will remain after 50% has been used. So the initial amount is always considered to be 100%, and 100%, 50% will be used, so we'll say minus 50%, and this will just give us a 50% remaining. All right, so 100 again is the same as 1 in standard form, and then 50% is 0.5 in standard form. So that's what we are going to use. Coming back to our formula, we are still using the same formula where we are saying K is equal to 2.303, like that, divided by T. In this case, we are looking for T, so we don't have anything to replace on T because that's what we are looking for. Then this will be log of, we have 1 on top there, which is 100% of the amount, and then what will remain is 0.5, like that. So this is what we have. Proceeding, this will give us K is equal to 2.303 divided by T, and this will have log of, now 1 divided by 0.5, this will give us 2. Yeah. So this is what we have for the 50%, and that's what we have for 75%. So this is what we have for the 50% here, and then on the other side we have for the 75%. So what we are going to do is we are going to equate our K. So this K here for 75% will be equal to K for 50%. For the sake of showing, let's show that this is K at 75%, like that, and this is K at 50%, like that. So we're equating these two. We're equating these two. So let's do that. Let's do that on the next page. So what we are saying is we're equating to say K at 75%, like that, must be equal to K at 50%. Since we are having the same conditions for this chemical reaction, it's a first order and we are having the same conditions. So what we found at K75 is that K is equal to 2.303, like that, divided by 60. We have a 60 there. That is multiplying by log of, on the other side, we have 4. And this must be equated to K at 50. We found that we have 2.303 divided by T, and this must be multiplied by log of 2. So that's what we have there. Now, when we reach this stage, we are going to cancel the 2.303 here and there. Since we have the same values on each side, we are going to cancel them. You can go through the cancelling mathematics, but they are going to cancel as you do that. So just cancel them at this stage. After doing that, you find that what we'll find is we'll have log 4 on top there, because cancelling that gives us a 1. 1 by log 4 will give us log 4. This will divide by 60, and this will be equal to, on the other side, we'll have log of 2 divided by T. Yes, so that's what we are going to have at that stage. Now, you are at liberty to do mathematics here. You can start by saying 2.303 divided by 60, then multiplied by log 4. You find your value here. Then you just say 2.303 multiplied by log 2. You find the value, cross multiply, and you're still going to find the same answer I'm going to find here. I've chosen to go through the usage of logarithm process here. Yes. So let's continue. Now, when you reach this stage, we're going to represent the left-hand side by, if you have log 4, this is log 4. Log 4 is the same as log of 2 to the power of 2. So log 4 is the same as log of 2 to the power of 2. And this log of 2 to the power of 2 is the same as 2 multiplied by log of 2. So now this part here is what we are going to replace where we have log 4. We'll say we have 2 multiplied by log of 2. So let's quickly do that. So now here we'll say we have 2 log of 2. We are replacing with what we found on the other side divided by 60. And this is equal to, on the other side, we still have log 2 that is being divided by t. When we reach here again, we'll see that we have the same log here. We have log 2 here and we have log 2 there. So those will cancel. And what we are going to have when we cancel those two is, we are going to say on the left hand side, we'll have 2 that is being divided by 60. And this will be equal to 1 that is being divided by t. Since we can see when log 2 goes there, it goes once and it will leave a 1. When you reach this stage, we'll just cross multiply. We'll have a 2t being equal to 60. And when we divide by 2 here, we also divide by 2 on the other side. This will just give us an answer which is 30 minutes. So yeah, it implies to say it will take 30 minutes for 50% under the same conditions to complete. So this is how we solve it. Again, as I said earlier, when you reach this stage here, you are at liberty to do mathematics where you are dividing the top part by the down part and multiply it by log of 4. You find an answer here. You also multiply 2.303 by log 2. You find an answer. Cross multiply, you do mathematics, calculate for t, you're still going to find the same answer found. That's if you are not familiar with the logarithm process that I just did here.